adding and subtracting fractions. So let's take this fraction, 2 over 3 plus 5 over 7. There's different ways of adding this. One way is to use a vertical method, 2 over 3 plus 5 over 7. Now, what we need to do is to look at this 3 and that 7, the denominators. What's common between 3 and 7? Multiples of 3 and 7. If you know your multiplication tables, it's going to be 21. If you didn't know, well, you take 3's and you add them up. So 3 plus 3 gives you 6, plus 3 gives you 9, plus 3 gives you 12, plus 3 gives you 15. Now, the 6, 9, 12, and 15 doesn't give you 7. So let's take 7 and then add them. Multiples of 7, 7 plus 7 is 14, plus 7 is 21. 15 and 21, they don't match. 14 and 9, 14 and 6, they don't match. These multiples of 3 and 7s don't match yet. Let's add more 3's to 15. 15 plus 3 is 18, plus 3 is 21. And now we have something where it matches. 21. Those, there are multiples of 3's that match with the multiples of 7's. And again, if you knew your multiplication tables, you know that 3 and 7, they have a common multiple of 21. So, what we want to do is we want to take 21 and create these equivalent fractions. We want to take 2 over 3 and make it a larger fraction, something that will accommodate a 21. How do we do that? Well, 3 times something gives you 21. Well, that something is 7 because there's 7 3's. So 3 times 7 gives you 21. 2 times 7 gives you 14. Same thing with the 7's. How many 7's do I need to make 21? Well, I need 3 of them. So 7 times 3 gives you 21. And then 5 times 3 gives you 15. And then we can take the fractions, the equivalent fractions, line them up, and we say 14 plus 15 over 21. We know that we add the top, the numerator, and that gives us 29 over 21. A lot of work. Again, you can do this different ways. This is not, this video is not intended to be analytical in terms of what the right way of doing it. Okay, cut, right? Cut. 29 over 21. Okay. So let's move on to the next problem. 2 over 3 plus 5 over 7. Same problem. Okay, let's move back. So let's look at the same problem. 2 over 3 plus 5 over 7. This time we're going to do it horizontally. Not a problem. What we want to do is we want to do equivalent fractions. And to do that, we got to match the denominators. We already know that the denominator needs to be 21. So 2 times 7, 3 times 7. We know that 5 over 7 needs to be 21 on the denominator. So 5 times 3, 7 times 3. And that gives you 14 over 21 plus 15 over 21. And when you add those, you get 29 over 21. And let's say we do the same one, 2 over 3 plus 5 over 7. And this is a whole unconventional way of doing it because you're not dealing with the lowest common denominator. But we can do it. So first step will be to multiply 2 times 7, right? Going from left to right, 2 times 7 is 14. Then let's not worry about the signs. 3 times 5, which gives you 15. And you notice that I'm writing that product on the right. The 2 is on the left, 14. The 5 is on the right, there's a 15. Divided by 3 times 7, which is 21, right? There is a plus sign in the middle, so I'm going to put a plus sign in the middle. Hey, we're getting the same numbers. 14 plus 15 will give you 29 over 21. Not bad. So let's take another fraction. 1 over 3 plus 2 over 5. Let's do this unconventional method. So 1 times 5 is 5. 3 times 2 is 6. 5 is on the left, 6 is on the right. Divided by 3 times 5 is 15. There's a plus in the middle, so there's a plus in the middle again. So 5 plus 6 over 15 is 11 over 15. Not bad. Let's try another one. 3 over 9 plus 5 over 6. Let's reduce 3 over 9 and rewrite it. 1 over 3 plus 5 over 6. All right, let's do the steps. 1 times 6 gives you 6. 3 times 5 gives you 15. And then 3 times 6 gives you 18. And what's in the middle? Well, there's a plus sign. 6 plus 15 is 21 over 18. And if you know your multiplication tables, we know that 3 goes into both. 21 and 18 gives you 7 over 6. Okay, what happens if you have a subtraction, right? What about if you're subtracting these fractions, 3 over 4, 2 over 5? What happens to this subtraction sign? Well, again, let's not worry about the signs, just let's do the math. 3 times 5 is 15. 4 times 2 is 8. Divided by 4 times 5 is 20. And what's in the middle? Subtraction. 15 take away 8 is going to be, use your fingers if you need to, 7 over 20. All right, let's try another problem. Negative 2 over 5 take away 6 over 8. And here you can tell that we have a negative and a subtraction. So what are we going to do? Not a problem. But before we start the pattern, let's reduce a 6 over 8. 2 goes into 6 3 times. 2 goes into 8 4 times. Let's rewrite that. Negative 2 over 5 take away 3 over 4. All right. So again, let's not worry about the signs. 2 times 4, that gives you 8. 5 times 3 gives you 15. And then 5 times 4, which is for the denominator, is 20. And again, we have a negative, right? Which goes right there. And then we have a subtraction, which goes here in the middle. So not a problem. If the signs are the same, then we'll just add the numbers. 8 plus 15 gives you 23. And keep the sign all over 20. Let's try something new. Let's try something like 5 over 12 take away 3 over 10. You'll notice that the denominator here is a little bit larger. One disadvantage of using this method of multiplying diagonally to add fractions is that the numbers can get larger, and if so, you're probably going to have to reduce in the end, which sometimes takes more time. But let's try it anyway. Let's try this one here. 5 times 10 is 50. 12 times 3, well, that's 12, 24, 36. All over 12 times 10, that's 120. And there was a subtraction in between the fractions, so we're going to put a subtraction in between 50 and 36. And 50 take away 36 is going to be 14 all over 120. Now, can we reduce? Sure we can, by 2's. 2 goes into 14 7 times. 2 goes into 120 60 times. And so we have an answer of 7 over 60. So in this case, we had to reduce in the end. Either way, vertical, horizontal, or multiplying it by this method by diagonals. There's other ways of adding and subtracting fractions, and that will be on our next video.